Hello student, today I am going to teach you a Kruskal algorithm. Kruskal algorithm is the very simple algorithm that is used in the graph to find out the minimum spanning tree. First of all, what is the minimum spanning tree and what is the use of it? The minimum spanning tree is the subgraph that covers all the vertices of the graph with minimum possible weights. There may be multiple minimum spanning tree in a graph, but among these graphs, the subgraph which has the minimum weight and which cover all the vertices is called the minimum spanning tree. First of all, this is a minimum MST. Okay, MST is MST. It is the subgraph which covers all the vertices graph with minimum possible. Right? So the MST of the graph is the minimum possible minimum weight subgraph that cover all the vertices in a graph. There may be a number of minimum spanning tree, but the minimum spanning tree has at the minimum weight. Okay. So the Kruskal algorithm is the technique which gives you the minimum spanning tree for a graph. What is the use? This kind of MST graphs are very useful in airlines. In airlines, a plane has to cover all the cities and it has to travel minimum distance without covering a circle. It means it's a minimum spanning tree. There should be no cycle in between and it covers all the cities with minimum distance by covering minimum distance. So the Kruskal algorithm is the one of the minimum spanning tree algorithm. Besides this, there is another Prince algorithm. I shall first, I am just writing the algorithm for the Kruskal algorithm. After that, I shall explain you with an example. So, I am writing this. this is the algorithm for the Kruskal algorithm, and I shall explain you one by one. Here, first we create an initially empty set A. A is an initially empty set, so A is equal to 5. After that, for each vertex, small b belongs to each. Now, for every vertex that belongs to the graph, at least for every vertex that exists into the graph, we make for every vertex we make set V. We make a set that how many vertex are there in the set, and we make a set capital V which represents all the vertices that exist in the graph. After that, we sort the edges into increasing order. After that, what we do, first of all, as according to the weight, we find out the order between the edges. We place the minimum edge at the first position, and after that, we keep on putting the increasing weights. And so we can say that we place the edges as per their weight in increasing order. After establishing an order between the edges weight, what we do, for each edge belonging to we start picking up weight one by one, starting from the smallest one. First, we start the smallest one. After that, when we pick that smallest node, we find out that if find set u is not equals to find set v. Here, find set u is initial set, and if we get by at when we pick an edge, then that edge contains two endpoints. As we know that in every edge there are two endpoints, and when we pick an edge, along with by picking an edge, we add two extra vertex to the set U. When we pick an edge, then the vertices associated with are added to U, and we pick our edge only if that vertex contains at least one vertex which has not been covered. So, if we pick an vertex, then it should satisfy the criteria that it should at least add one extra vertex to the previous set. If it is not, if there is an edge whose both vertex are already covered, already in the vertex set U, then we do not add that edge into our set. Set A. Here A is the set that was initially empty. Now, after when we find out that in this edge there are vertices which has not been added, then we add that edges to our set to construct the minimum spanning tree. Like this, we keep on adding different edges to the set, and the final combinations of these edges gives us the minimum spanning tree for the graph. Here we check out that when we consider an edge, it should not create cycle. When we pick an edge that has vertices that are already member of the previous set, then it means that it would connect two already existing vertices. It means it will create a cycle. So this step is actually to prevent formation of cycle in the minimum spanning tree. As the name represents that this is the minimum spanning tree algorithm, so there should be no cycle. To prevent the construction of cycle, we make sure that find set U is not equal to find set V, or simple word we can say that no edge is creating any cycle in between the already existing vertices. So this is called the Kruskal algorithm. We arrange the edges as per their increasing order, and then after that we keep on picking the edges which add some extra vertex that was not been already added. And finally we keep on combining these edges until all the vertex of the set V has been covered. When all the vertex of the set V has been covered, then we stop and at that point and we get the minimum spanning tree. Here, for every edge, we are checking that whether the next edge is adding extra edge or not. So we are adding each vertex with some other vertex. It means at least uh, there are 2 points. So for each vertex, we are finding out that the vertex is connected. So its complexity is E log E or E log V. So its complexity is E log E or E log V. So its complexity is E log V. Here, between the vertex, when we add an edge, then the vertex are associated with it. So we can equally say that its complexity is E log V. So, in this set, what we are doing, we are adding one edge with another. So in this way, when we keep on adding, this will take, and it means for every edge, we are at least, since each edge is connected with 2 nodes, so basically we are constructing E nodes with log V base 2. Log V base 2 number into log base V base 2 number of times to the other edges. So they are adding one by one with one another, there is equal possibility. So the overall complexity is V log E or V log V. Now I shall take an example, and with help of which I shall explain the procedure of Kruskal. I am constructing a graph. Here I have drawn a graph. In this graph, there are the vertex set B is equals to A, B, C, D, E, F, G, H, I. So this is the vertex set B. Here, our minimum spanning tree stops when we have found all the vertices that exist in the graph. In the first step, what we do, we mark all these edges into the increasing order. So first, here the edge in the ring, edge and ring. First edge is HG, H comma G, and weight is 1. The next edge is 2GF is 2. The next one is AB. AB is equals to 4. And after this, the next one is IG. IG. IG equals to 6. HI. HI is equals to 7. Then EC. EC equals to 8. Now there are 2 edges which are of 2 edges of A weight 8. AH. AH is also of weight 8. Now next one BC of BC equal CD. CD of weight 9 and EE. EE of weight 9, and finally the HFE of weight 10 and BG, B, H of weight 11, and at last the HTF of weight 14. So here what I have done, I have written all the possible edges in the graph into the ascending order. The weights of the edges are in ascending order. After this, I shall perform a union operation. I shall take an set A that is empty. Now I shall add an edge into the set A, first picking up the smallest one. I shall pick, suppose, the vertex H, G. So I pick HG a vertex. I am marking it by the double line. Okay, this vertex is covered, this set is covered. By adding this, I got a set. The final set was A union. U, V. So I will get a set union H, G. So A would become H, G. Right? Now after this, this is covered. Right? Now after this, the second vertex is GF. By adding union, performing a union over this, A union, performing the union over GF. One vertex is common, but we are getting a new vertex F. So the set becomes equals to H, G, F. So GF. Okay, and double mark. After this, right, this third vertex is A. The edges may be disconnected also in Kruskal. It is allowed. Now we shall perform union over this AB. Now the set would become A, B, F, G, H. I am writing this in order to check out that we have got all the vertex or not. Okay, so now after this union, but A is this one. Now after this vertex is covered, this is covered, this is covered, this is covered. Now the next vertex is IG. So IG is there is an extra vertex I. So after union, so I am just taking the union over this union operation over IG. I, G. So after this, it will become, I'm just writing this function. B is equals to, okay. Now this equals to A is equals to A, B, F, G, H, I. Right? Now this has also been included. So AB has been included, IG has been included. Right? After this, the next vertex is HI. But there is a problem, because by adding the vertex HI, we shall add two vertex to the set. But these two vertex are already present in the set, and they are same as the previous step. That there is nothing is being added to the set A, so we shall discard this one. We shall not add this one. Right? After this, the next vertex is BC. BC is equals to A. By BC, we are getting an extra vertex C. So after this, we shall get union, performing union BC, B, C. We shall get A is equals to A, B, C, F, G, H, I. Right? Now the next vertex is AH. A is already present, H is also already present. So this will be discarded because we will get the same set after adding this H. So this indicates that there will be AH. When we will combine AH, the A is already in the circuit and H is also in the circuit. So we shall not add this because A is already present and H is already present. So we shall not add this one, right? So after this, we shall form CD. CD. We shall add CD. Okay. So by adding CD, we shall get a union C comma D. So A will become equals to A comma B C D F G H comma I. Right? Now next is DE and DE. This one D is not in the set, so we will remove this one also. Okay, so union DE. We will get A is equals to A, B, C, D, E, F, G, H, I. Okay, right? And here A, B, C, D, E, F, G, H, I. So here I have got the I have got all the vertices, but this has created all the vertices. But here we shall check that is there any possibility. Now the next vertex is D E is included. Next one is F E. Okay, F E and F E is equals to 10. This would not be when F E will create. Both the vertices are already present, so we will not consider this one. Next is BH, BH and BH. BH will not, it will, both are present, so it will not be added. And DF, DF. So DF is 14, D is already present, F is also already present. This will not be considered. So here we shall, one point here, we have added 1, 2, then 4, and after that this one. Here there is a point that we should, so this is the minimum spanning tree with help of which we will get all the vertex and we shall get the final result in which all the vertex are covered through this minimum spanning tree. So finally, to add on this, we shall add an extra vertex to connect all these points AH after this, and by adding this, there is no cycle in between these two components. Since these two were different components and they were not connected to each other, to finally connect these two components, we shall add an extra edge AH so that we get the connected component. If we do not get a connected component, then we add an extra edge that may not add an extra vertex to the set, but that connects those two components. In that situation, we are allowed to add an extra edge that do not create if they are two different components. So this will be the minimum spanning tree for the given tree. So the complexity of the Kruskal algorithm is E log E or E log V, and it gives you a subgraph that connects all the vertices of the graph with minimum possible weight. So now the weight of this subgraph, that is the sum of the weight 1 plus all these edges, 1 plus 6 plus 2. We shall add all these values together and we shall get the result. So here 1 plus 2 plus 6 plus 4 plus 8 plus 8 plus 9 plus 9. The sum of all these will be the 47, around 47, this number is 47. number 47, this would be the weight of the minimum standing wave. This is used to find out the optimal route for the airlines so that the plane travels to all the cities and it travels the minimum distance. So that's all.